Next is the path function and point function. Now what are point functions? The functions which does not depend on the path followed by the system. All such functions are known as point function, and the functions which depends on the path followed by the system are known as path functions. The example of point functions, all the properties of the system, because the properties do not depends on the path followed by the system. Okay, I will tell you. Okay, so let's suppose we are having any process from suppose point 1 to point 2. This is a PV diagram. Okay, if I ask you what is the change in pressure in this particular process, you would say del P is equal to P2 minus P1. Okay, what is change in volume? Del V is equal to V2 minus V1, whatever. Now if I change this path, okay, suppose initial path is, let's suppose A, if I am changing this path to B, okay, now what would be the change in pressure now? So again this pressure change would be P2 minus P1, volume change would be V2 minus V1, temperature change would be T2 minus T1, and so on. So all these properties, all such properties which do not depends on the path followed by the system, whether you take any path, the change remains constant. Such functions are known as point functions which do not depends on path followed, and these are all properties of the system as we have discussed. Okay. Now what about the path function? The function which depends on the path followed by the system. For example, heat, for example, work. So as we know, area under PV diagram gives work done. So if I ask you what will be the work done in the process, in the path during path A, so the area under this PV diagram will give us the total work done. Now if I am changing the path, suppose the path is now changed to path B, now what will be the work done? So the area under this PV diagram, this total area will give us the work done. That means the work done is something which is depending on path. Okay, and similarly heat transfer, the area under TS diagram gives heat transfer. Okay, so all such functions which depends on per path followed by the system are known as path function, and all such functions which depends on the, which does not depend on path followed are known as point function. For example, all the properties of the system. Okay, now the question arises, how can we check whether certain property is the, whether certain function is the property of the system or not? किस तरीके से हम वो चेक कर सकते हैं? So one thing we know that if it is a point function, then it has to be the property of the system. Okay, all the properties are the point function. Okay, so we will have to check whether that function is a point function or not, and the easiest method to check any function whether it is a point function or not is to see whether the differential of that function is exact or not. Okay, for example, let's suppose we are having the function dp is equal to m dx plus n dy. Okay, this is the function we are having. So we just have to check whether the differential of this function is exact or not. And for exact differential, as we know from mathematics that del m by del y at constant x, this should be equal to del n by del x at constant y. Okay, if it is following this relation, then we can say that the differential is exact, and this particular function is the point function and the property of the system. Now what is the meaning of this exact differential? क्या होता है ये exact differential और इसको हम किस तरीके से समझ सकते हैं? Why we are saying कि अगर differential exact है then it is a point function. So just understand this thing very carefully. Exact differential means if we can integrate, suppose we are having any function जिसका curve, the graph we are getting like this. Okay, and let's suppose we can integrate this between these 2 points without requiring any relationship between the variables. ओके, चेंज ऑफ वेरिएबल्स के बीच में रिलेशनशिप के बिना ही अगर मैं इसको इंटीग्रेट कर पा रहा हूँ बिटवीन 2 पॉइंट्स, देन वी कैन से दैट इट इज़ अ पॉइंट फंक्शन. दिस डज नॉट डिपेंड्स ऑन पाथ एंड हेंस इट इज़ अ पॉइंट फंक्शन एंड हेंस द डिफरेंशियल इज एक्जैक्ट. I will give you one example. Let's suppose we are having one function. Just understand this example and you will understand this thing. Let's suppose we are having a function p dv plus v dp. This is the function we are having. We have to check whether this is the point function or not. So how can we check? Now further we can write it as p dv plus v dp can be written as d of pv. Yes. Okay. Now if I want to integrate it, I can directly integrate this, integration of d of pv. Now here I don't require any relationship among p and v. This integration of pv is directly equal to integration of d of pv is directly equal to p into v. So without any relationship between pressure and volume, between variables, we can integrate this between 2 points. Such functions are known as this. For such function we can say that the differential is exact and hence they are the point function and hence the property of the system. Getting this or not? Okay. On the other hand, another example, on the other hand, suppose we are having the function, let us suppose PdV. Now, if I want to integrate this, integration of PdV, now this integration of PdV will, for integrating this PdV, we require certain relationship between P and V. The P should be in terms of V, then only we will be able to integrate it. Getting this or not? So, for such functions, this where the certain information is required between the change of variables, okay, then we can say that differential is not exact, and hence it is not the point function, it is the path function. So, this integration of PdV is not an exact differential, and hence the path function, okay, and this PdV plus VdP, here the differential is exact, and we can say it is the point function. Getting this or not? Okay. Another example we will see, let us suppose the third example, another function we are having v by t dp plus p by t dv. Now, how can we check such function whether the differential is exact or not? So, I told you the process. If the differential is exact, then del m by del y at constant x, this should be equal to del n by del x at constant y. So, we just have to check this thing. Okay. Now, here in this particular function, we can compare this with dp is equal to m dx plus n dy. Okay. Now, here m is equal to v by t, just compare this and this, m is equal to v by t, x here is p, n here is p by t, and y here is v. Getting this? Okay. Now, what will be del m by del y here? So, this del m by del y at constant x, this should be equal to del by del v of v by t, where p should be kept constant. Okay. Now, this v by t can be further written as we know p v is equal to r t. So, this v by t can be written as r by p. Okay. So, you can write it as this will be equal to del by del v of r by p, okay, at constant p. Okay. Now, r is a constant, p is again a constant. So, this del m by del y at constant x will be equal to 0, first thing. Now, what about del n by del x at constant y? So, this del n by del x at constant y, this will be equal to del by del p of p by t, okay, at constant v, okay, or you can say del by del p of r by v, p by t can be written as r by v at constant v. Okay. Now, again this r is constant, this v is constant. So, this del n by del x at constant y will be equal to 0. So, you can say what, del m by del x at constant, sorry, del m by del y at constant x is equal to del n by del x at constant y, which is equal to 0. Hence, this function is having the exact differential, and hence it is the property of the system, or it is the point function. Okay. So, this is how you can check. If you are having any function, you can check whether that function is a point function or a path function. Getting this or not? Now, coming to few more definition. First is thermodynamic state. Now, if all the properties are having a certain value, a definite value, the system is said to be in a particular state. For example, in any particular state, let us suppose the pressure is P1, volume is V1, temperature is T1, and so on. So, if all the properties are having a certain value, the system is said to be in a particular state. If any of the property changes, if the value of any of the property changes, the system is said to have the change of state. That means, the state of the system will change. This is called as change of state. If any of the property changes, the system is said to have change of state. Now, the succession during this change of state, the system will pass through many points, many different states. So, the succession of all those states is called as path. If I draw the succession of all change of state, all different states which the system is passing through, that succession is known as path. If that path is completely specified, suppose we know that this change of path was at constant pressure or at constant volume. So, if that path is completely specified, then that becomes process. And what is a cyclic process? If the initial state of the system is same as that of the final state, if the system is going through the number of change of states such that the initial state of the system is same as that of the final state, then we can say that the process is the cyclic process. Okay. So, let us suppose initially the system is having certain properties. Let us suppose pressure is P1 and volume is V1. So, system is said to have in a particular state. If any of the property changes, suppose the pressure is changed or the volume is changed or the both are changed or temperature is changed, whatever properties are changed, the system will said to have the change of state. Let's suppose the final state of the system is at P2 and V2. Okay, now during this change of state, the system is passed through number of states. Okay, it is not certain कि सीधा P1 V1 से सीधा P2 V2 नहीं आएगा. It will pass through many such states. If I draw the succession of all those states, this succession of all this state is nothing but the path. This is the path followed by the system. जिस path से वो system जाता है, that is known as a path followed by the system. If this path is completely specified, if we know some relation of this path, that suppose this path is at constant pressure, ये constant pressure में हो रहा है, or this path follows the relation, suppose PV to the power gamma is equal to constant. Okay, so if that path is completely specified, that becomes the process. Okay, and what is the cyclic process? If the system is passing through number of states, suppose system is passing through three different processes, sorry. Okay, this is 1, 2 and 3 different processes the system is passing through, such that the final point of the last process is same as the initial point of the first process. Then we can say that the system is said to have the cyclic process. Okay, so when all the properties are specified, it is said to have in a particular state. If any of such property changes, system is said to have change of state. If we draw the succession of all change of states, it becomes path. If the path is completely specified, it becomes process. Okay, and if the initial state of the system is same as that of the final state, then we can say that the process is a cyclic process. Okay. Now next is the homogeneous and heterogeneous system. Now what is a homogeneous system? A system in which only one phase is present. As we know, majorly there are three phases: solid, liquid and gas. So if a system consisting of only one phase, then it is known as the homogeneous system. And if the system is having more than one phases, then it is called as the heterogeneous system. And how can we define a phase? Suppose we are having a certain quantity of matter which is homogeneous in chemical composition as well as in physical structure, then it is said to have a particular phase. And if the system is having only one phase, it is called as homogeneous system, and if the system is having more than one phase, it is called as the heterogeneous system. Next is the thermodynamic equilibrium. Now what is the thermodynamic equilibrium? Equilibrium, as we know, is something which is stable. Okay, that means nothing changes there. So thermodynamic equilibrium means if the macroscopic properties of the system are not changing when the system is isolated from the surrounding, then we can say that the system is said to have in a thermodynamic equilibrium. If the macroscopic property, any macroscopic property of the system is not changing, for example temperature, pressure, volume, whatever, any macroscopic property of the system is not changing when the system is isolated from the surrounding, then we can say that the system is in thermodynamic equilibrium. Now in order to be in thermodynamic equilibrium, the system must follow three types of equilibrium. First is mechanical equilibrium. Mechanical equilibrium means there must be no unbalanced forces, because basically mechanical equilibrium disturbs because of unbalanced forces. If the pressure inside the piston cylinder, inside the cylinder is more as compared to outside, then it will pull the piston upward, and the mechanical equilibrium will be disturbed. So the very first thing it should follow the mechanical equilibrium. Second thing, it should follow the chemical equilibrium. Okay, that means the chemical equilibrium, as we know, the forward reaction should be equal to backward reaction. No further chemical changes should take place in that particular system. And third, it should be in thermal equilibrium. That means the temperature of the system will remain constant. Okay, so if all these three types of equilibrium are followed, then only we can say that the system is in thermodynamic equilibrium. If any of the three equilibrium is disturbed, then the thermodynamic equilibrium of the system is disturbed.